Hi, this is John Hayes from Engineering.com, and we are here with Albert Einstein at the USA Science and Engineering Festival. One of the questions I have to confess is I've never really understood the special theory of relativity particularly well, Professor Einstein, and I'm wondering if you might help us out.
The actual special theory of relativity had to do with a puzzle, which was the constant speed of light. That the speed of light was measured as the same in no matter what your frame of reference was, no matter how you were moving. In a nutshell, I will tell you, if I am standing still and someone is walking between you and I at 10 miles an hour, and they are walking at 10 miles an hour, and you measure their speed as 10 miles an hour, and so do I. But now, if I sit on a rolling chair and someone pushes me at 5 miles an hour, well, they are walking at 10 miles. I'm being pushed in the same direction as at 5 miles an hour. You measure the speed of the person walking as 10 miles an hour. But I no longer measure the speed of that person as 10 miles an hour. What do I measure that person's speed as?
I'm going to guess 5 miles per hour.
5 miles per hour, exactly so.
I feel so good about myself.
Very good. If I was being pushed at 10 miles an hour, I would be standing still relative to them. This is called the addition and subtraction of velocities. No puzzle. But now use your imagination and imagine that the person walking is instead a beam of light. Whoosh! They fly by at 186,000 miles per second, or 300,000 kilometers per second. We will use miles for now. You measure their speed as 186,000 miles per second, and so do I. But now, the same person comes to push me on the little chair with wheels, and they are able to push me at 100,000 miles per second. Oh, they have eaten some special K. So now, the speed of light, whoosh, 186,000 miles per second. Little whoosh, me on my chair, 100,000 miles per second. You measure the speed of light as 186,000 miles per second. What do I now measure the speed of light?
86,000?
A very, very reasonable, rational answer, but wrong.
Excellent.
No matter how fast the person is pushing me on my little stool, I will still always measure the speed of light the same as you do. 186,000 miles per second. Because from all frames of reference, the speed of light is measured the same. How could this be possible? Well, the only way that this could be possible, and to do this, I had to throw out all the laws of physics. And I had to tell myself, well, what would the laws of physics have to be like for the speed of light to be the same in all frames of reference, and for the laws of physics also to be the same in all frames of reference? And the clue to the answer is what is meant by speed. If speed equals distance divided by time, and the speed, in this case the speed of light, must always be measured the same, but two things still can change.
Yeah, distance and time.
Yeah, then I used my imagination. I said, what if the real laws of physics are such that when one frame of reference moves relative to another frame of reference, what if the measurement of distance changes? And what if also the measurement of time changes? And what if these changes are very small at everyday speeds? So we would never notice it in our day-to-day life. But what if these changes grow greater and greater, so faster and faster as we travel? So by the time we are approaching the speed of light, the changes are enormous. Everyone always imagines that a mile always measures the same mile. A second always measures the same second. But what if, when you move, distances become shorter and time is measured more slowly? What would it appear? Well, very quickly, if I was sitting on my chair and being pushed at 100,000 miles per second, and you could see me at that speed, what would you see? You would see the measuring rod I hold in my hand that was once equal to your measuring rod. To you, my measuring rod would appear to grow shorter. And if you could see my clock that once ticked precisely like yours, to you, my clock would appear to be ticking more slowly. And what would I see? Well, the laws of physics are the same in all frames of reference. So to me, I would be standing still and you would be moving. And I would see your measuring rod grow shorter, and to me your clock would be ticking more slowly. This is a little complicated to understand on what they call the first blush. The important thing is that there is no real mile. There is no real second. Every frame of reference carries with it its own measurement of time and space. And in point of fact, my friends, what we call time and what we call space are not two separate things. They are one thing together. We now call space-time. You will see that on all the Star Trek shows. That's where it comes from, space-time. And when anything moves, time and space rearrange themselves in such a way that the speed of light, the real constant of the universe, is always measured the same by everyone. And that, in what they call in a nutshell, is the special theory of relativity.